Hello everyone, I am Dr. Dinesha, HE. Today I will explain about ethers, which is the part of chemistry syllabus for third semester. Ethers are organic compounds in which two alkyl or aryl groups are attached to a divalent oxygen atom. These are represented by general formula RO R-, where R may be alkyl or aryl groups. These are the examples of ethers. In this case, oxygen atom is attached to methyl group on one side, another methyl group on another side. In this example, oxygen atom is attached to ethyl group on one side, another side also ethyl group. There are two types of ethers: simple ether, which is also known as symmetrical ether, when alkyl or aryl groups are same. These simple ethers are generally represented as ROR. We have another type of ether, that is mixed ether. This is also known as unsymmetrical ether. When alkyl or aryl groups are different, this ether is known as mixed ether. This can be represented as RO R-, where R and R- are different alkyl groups. These are the examples of simple and mixed ether. The oxygen atom is attached to two methyl groups. So this is a dimethyl ether, this is simple ether. In this example, oxygen atom is attached to two ethyl groups. So this is also simple ether. Here, third example, oxygen atom is attached to methyl group and ethyl group. So alkyl groups are different. So that's why this is mixed ether, methyl ether. In the fourth example, the oxygen atom is attached to methyl group on one side, benzene ring on another side. So alkyl groups are different. So this is also mixed ether. Nomenclature of ethers. There are two types of system for naming the organic compounds. First one is common system and another one is IUPAC system. In common system, simple ether are named as dialkyl ether. For example, diethyl ether, dimethyl ether. If alkyl groups are different, they are named in the alphabetical order. For example, ethyl, methyl ether. In common system, this compound is named as dimethyl ether because oxygen atom is attached to two methyl groups. The second example, oxygen atom is attached to two ethyl groups, that's why this is named as diethyl ether. This is a mixed ether where oxygen atom is attached to methyl group and ethyl group. So one is ethyl group and another one is methyl group. So we have to name it as alphabetical order. So ethyl, methyl, ether. So this is also oxygen atom is attached to methyl group on one side, benzene ring on another side. So this is named as methyl phenyl ether. Ethers are named in IUPAC system as follows. Generally, ethers are named as alkoxy-alkane in IUPAC system. Mixed ether are named as follows. The smaller group, which is containing less number of carbon atom, is made into alkoxy, and larger group, which is having more carbon atom, is made into alkane. For example, methoxymethane, methoxyethane, methoxypropane. So in the first example, the oxygen atom is attached to two methyl groups. So one of the alkyl group is made into methoxy and another one is made into alkane. So the name becomes methoxymethane. Here also oxygen atom is attached to two ethyl groups. So name becomes ethoxyethane. But in this case, in the third case, oxygen atom is attached to methyl group on one side, ethyl group on another side. So methyl group becomes smaller alkyl group and ethyl group becomes larger group. So larger group is made into alkane, smaller group made into oxy. So name becomes methoxyethane. In the fourth example, oxygen atom is attached to methyl on one side, benzene on the another side. A smaller group becomes methyl group. So this is made into oxy, that means methoxy. And larger group, which is benzene ring, so we'll take benzene as it is. So name becomes methoxybenzene. Let us move on to synthesis of ether. There is one method which is most important and widely used for the synthesis of ether, that is known as Williamson ether synthesis. This method includes the reaction of alkyl halide with the sodium alkoxide. When an alkyl halide is allowed to react with sodium alkoxide, symmetrical and unsymmetrical ethers are formed. This can be represented as a general equation RONA, that is sodium alkoxide, reacts with RX, that is alkyl halide, to give ethers. Aromatic ethers can be synthesized by Williamson ether synthesis. Sodium phenoxide reacts with alkyl halide to give aromatic ethers. Let us see some examples of Williamson ether synthesis. Sodium ethoxide reacts with ethyl bromide to give diethyl ether. In the next example, sodium tertiary butoxide reacts with methyl bromide to give tertiary butyl methyl ether. Aromatic ethers also synthesized. For example, sodium phenoxide reacts with methyl bromide to give methyl phenyl ether. Next, we will move on to reactions of ethers. The first reaction is cleavage of ethers. Ethers undergoes cleavage when they react with hydrohalic acid to give alcohols and alkyl halides. For example, ethyl methyl ether undergoes cleavage when it is reacted with hydroiodic acid to give ethanol and methyl iodide. Another example, diethyl ether reacts with hydroiodic acid to give ethanol and ethyl iodide. Another very important reaction of ethers is autooxidation. Ethers undergoes autooxidation when they exposed to air. Ether reacts with oxygen in a slow manner to give hydroperoxides and dialkyl peroxides. For example, di-tertiary butyl ether undergoes oxidation to give di-tertiary butyl hydroperoxide and di-tertiary butyl peroxides, which are known to be explosive. Next, we'll move on to estimation of ether by Giessel's method. The method was developed by S. Giessel in 1886. In this method, the ether is heated with excess of hydroiodic acid, forming an alcohol and iodomethane. The formed iodomethane is distilled off and reacted with alcoholic silver nitrate to give silver iodide. The resultant silver iodide corresponds to methoxy group. 1 mole of silver iodide precipitate corresponds to the presence of 1 methoxy group. The reactions which are involved in the Giessel's method are ROCH3, that is, this is the methoxy group, ROCH3. This reacts with hydroiodic acid to give alcohol and methyl iodide or iodomethane. This iodomethane reacts with silver nitrate to give methanol and silver iodide. The precipitated silver iodide is measured and The number of moles of silver iodide corresponds to the presence of number of methoxy group. If we get 1 mole of silver iodide, that is corresponds to 1 methoxy group. If we get 2 moles of silver iodide, that compound contains 2 methoxy group. These are the some reference. And finally, I thank you everyone for watching.